Good morning and welcome back to this video series. In our previous examination of the scialytic lamp's history, we observed the evolution from concept to actuality. Our study traced its origins back to 1919, when Professor Louis Véran at the University of Algiers created the initial surgical lamp prototype. Fast forward to the present day, where modern scialytic lamps stand before us as a product of this rich history. We observed a shared feature among all these lamps, indicating a common element to their design, namely the desire to control light. Well, yes, because controlling light is crucial in the operating room. The main function of the surgical lamp is to provide a focused source of light, specifically designed to illuminate a particular area known as the operating field. The question now arises, how is it possible to control the operation and adjust the intensity of this light? Controlling light is achievable solely through reflection, as the only viable method in this context. Reflection then has been the basis of the technological development of the product. Let us try to understand more about it. What then will we look at today? Today we will address the different reflection technologies. Together we will address the two types of reflection that exist, indirect reflection and direct reflection, and we will offer some physical background to better understand how light is controlled. So let's begin. Let's start by looking at indirect light. Indirect reflection has been the foundation for any technological development. During its early stages, the concept of light transmission revolved around the interception of light emitted from a source by a reflective surface, which then carried and conveyed it to a specific destination point. By means of reflection, we possess the capability to manipulate light, altering its trajectory and course to a certain extent. Through this process, we attune its path without compromising its fundamental properties. We will not be able to bend light rays, but we can channel them. So let us try to understand how this convoying of light beams takes place. Different surfaces do not illuminate or reflect in the same manner as each other. The way in which reflection occurs specifically is dependent on the shape of the surface and also on the material. Now, this video is not intended to be a physics course, but together we will try to address how, by manipulating the shape, one can effectively manipulate the reflection of light. Let's examine the primary shapes. Initially, we'll analyze three standard shapes that enable reflection. Let's take a closer look at how a prism, an ellipse, and a parabola reflect. Then we can delve into the reflection of light through more complex shapes, such as the elliptical mirror and the Fresnel glass. Through this exploration, we can gain a deeper understanding of the phenomenon. In each of these three examples, what we notice is the fundamental characteristic of a wave. In this case, a light wave which, subsequent to an impact, changes direction. When considering reflection, it is important to acknowledge the presence of two types of rays. The incoming ray that strikes the surface is called the incident ray, and the reflected ray, that is the one that leaves the surface. The angle between the incident ray and the perpendicular to the surface is therefore called the angle of incidence, while the angle between the surface and the reflected ray is called the angle of reflection. In regard to these angles, there are two fundamental guidelines that must be followed. First, the incident ray, the reflected ray, and the perpendicular to the reflecting surface at the point of incidence belong to the same plane. 2. The angle of incidence is equal to the angle of reflection. In essence, in reflection, the red angle will always be equal to the green angle, while the angle between them will always be 90 degrees. This is the fundamental principle behind every indirect reflection lamp. More or less complex, but it all starts from this first rule. The angle of incidence is equal to the angle of reflection. This rule has played a crucial role in the progress of halogen surgical lamps development, ensuring their success. In fact, we have to wait until 2002 when RIMSA proposed to the world the first lamp with LED technology. The LED, in fact, in addition to bringing about a transition in the technological evolution of medical devices, allows new forms of reflection to be considered. It provides us with the ability to shift away from previously deemed dogma, indirect reflection, embracing new perspectives and breaking free from limiting beliefs. What then is indirect reflection? Direct reflection is a reflection system whereby the light source creates a light beam that insists directly on the illuminated body. How? Well, analyzing how still leads us to reopen the pages of physics textbooks to go deeper into two concepts that were probably not that necessary when we were considering only systems with indirect reflection, namely that of convergence and divergence. In the case of convergence, a bundle of rays hits the surface and causes a transformation in its design and outline, concentrating the direction of these toward a point, the optical center, or in our case, the operating field. On the other hand, in the case of divergence, the beam of parallel rays, upon encountering the surface, will change its trajectory by making the direction of the individual rays coincide with the direction they would have had if they had not been parallel. In other words, the rays that are parallel to each other are portrayed as extensions of their direction starting from the optical center. In the operating room, divergence enables the scattering of light, resulting in two types of reflection. Hence, we observed indirect reflection as well as direct reflection. They are two different technologies. Each has its advantages and each has its disadvantages. So let's try to delve into what are the advantages of one and the disadvantages of the other. Based on the way the topic is presented, it may give the impression that indirect lighting is a technology of the past, specifically associated with halogen surgical lamps, while direct reflection is more commonly linked to the future. In fact, it is the technology we have presented with reference to the LED, and perhaps we are led to believe that precisely indirect reflection is something outdated, while development should take place with direct reflection. This is not really the case. Both types of reflections, however, have their own sets of pros and cons to consider. When comparing the two, it is important to evaluate the light-emitting surface area as well as the level of glare produced. Firstly, let me clarify the concept of light-emitting surface area. It refers to the total area of the surface that reflects light. Cast in the context of operating lamps, it coincides with the effective area of the dome from which the light is emitted. And why can it as well as not coincide with the total surface area of the dish? Precisely according to the reflection technology adopted. When considering indirect reflection, let's examine halogen lamps as an example. In this instance, we observe how the bulb, positioned at the center, reflects its rays onto a parabola that matches the size of the dome's diameter. The dome then further reflects the light onto the surgical field. This system demonstrates the reflection of light over the entire surface of the lamp, which is then a light-emitting surface. In this case, the light-emitting surface area totally coincides with the diameter of the lamp. In contrast, let us take the case of lamps with a direct light reflection system. In this instance, it's improbable that the light emission area has a complete coincidence with the dome surface area of the reflector. Why is this so for this case? It is simply intrinsic to this specific technology. When light is emitted from a source and propagates through space, indirect reflection allows for a maximization of the surface area of light emission. However, unlike diffuse light, the light in indirect reflection is concentrated. Such characteristics are closely dependent upon the technology. So how is it concentrated? It is concentrated through the use of lenses, of converging lenses. So the surface of the lamp will be populated with many LEDs, with many lenses from which the light comes. So the surgical field will no longer be illuminated by a single beam of light, but will be the collection of several beams of light that, insisting all on the same point, will illuminate the surgical field. Can we say that these two solutions are equivalent? Under test conditions, perhaps yes. But dropping them into their actual use, we see how there are numerous differences, i.e. the incidence of the same obstacle has a different weight in the case of a solution with direct light and a solution with indirect light. We see how the incidence of the Same obstacle in a surgical lamp with direct reflection has a much greater incidence than in a similar solution displaying indirect lighting technology. Why is this? Precisely because of the light-emitting surface area, because the greater the light-emitting surface area, the lower the incidence of this obstacle will be. But let's move on to the second advantage that should not be underestimated. One major advantage of using indirect light is its ability to reduce glare, both in reality and perception. This makes it possible to minimize the discomfort caused by excessive brightness that affects visual clarity. On the surgical field, because the rays, by not directly insisting on the operating field, do not result as annoying and distracting to the eyes of the user. In fact, it has been proven that by comparing two different solutions, one with direct light and one with indirect light, the quantity of light measured in lux reaching the retina at different viewing angles was consistently lower when using an indirect lighting solution compared to other options, chiefly a direct lighting solution. Now, glare we will address in a dedicated video precisely because of the relevance of the topic and its importance. However, we have limited ourselves to offering a brief overview of it in this context precisely to help you understand the advantages and disadvantages of reflection technology. In our dedicated videos, we will also discuss the secondary advantages of one technical solution over another. This will be done in addition to addressing other aspects previously mentioned. We will leave to other videos the analysis and in-depth discussion of product life, safety, of temperature, of laminar airflow compatibility. To conclude, opting for an indirect light solution is consistently more desirable than going for a direct light solution. The advantages of indirect lighting should never be overlooked. The advantages of indirect lighting are numerous, starting with the maximization of the light-emitting surface area. This significantly increases the quality and spread of illumination. And second is the reduction of glare. Have a nice day.